Is this slide visible to you on your screen?
जी सर.
Okay, that's great. So we are in week number 13, and we have in fact today's lecture has been divided into, rather this week's lecture has been divided into three parts. So we will be covering 13.1 and 13.12 today, and 13.3 in tomorrow in 1 hour class. So we would be talking about the manufacturing operations. So this is our second last week. No, not second last week. This is our third last week. So we will have 2 more weeks of studies, and we will cover 2 more topics after this. So we are going to talk about manufacturing operations today. So let me just first define the technological definition of manufacturing process. So let me just pick up the I'll go with magenta color today because this slide already has some colors in it. So I'm going to go with the magenta color today. So let us define the technological uh, definition of manufacturing. So I'll just read it for you, that application of physical and chemical processes to alter the geometry. So number one is that these are some physical and chemical processes which are used to change or alter the geometry, properties or appearance of a given starting material to make parts or products. So this is actually the finished product. So uh, conversion of raw materials into finished product with the help of some physical or chemical processes. So we convert it into finished product. So here you go with the finished product. So what does the manufacturing include? It may include the joining of multiple parts. So it can be an assembly operation. So it can be an assembly operation to make and assemble products, or it can be accomplished by combination of machinery. By combination of machinery, we mean that we are going to use some tools, powers, or manual labor to carry out some process on the work part. So combination of machinery. So this is actually uh, uh, using some tools. Maybe those can be power tools, or those can be and manual labor can also be applied on this. So this is going to carry out the manufacturing for us. It is almost carried out as a sequence of operations. What does it mean? That sequence means that it has to undergo a certain sequence. Like let's see, if what I have written here is that we have, let's see, n number of stations starting from 1, 2, 3 and n up to n. So station number 1, we are carrying out the turning. So this is the turning which is being carried out at station number 1. Then there is some heat treatment which is being carried out at station number 2. Then painting is being done at station number 3, and then there are a number of stations in between in which some process is being carried out, and finally at the last station, nth station, so we are carrying out the packing of the material. So this is how a raw material is converted into a finished product with the help of manufacturing. So this is the technological definition of manufacturing. So let us move forward, and whatever we have discussed in the last slide, so that is shown here in the form of a figure, in the form of a picture, which tells us that this is the raw material which is coming in. It is going through certain manufacturing processes here, and those manufacturing processes are being carried out with the help of machinery, tool, power, or labor, and then this is the complete part of the product which comes out in the form of a finished product, and some scrap or waste that goes into waste, which does not form part of the finished product. So this is what would be a waste, that if it does not qualify for the um, quality, so your product is going to go into waste. Or scrap is something which is the material removed from the finished product, from the raw material, to give it a shape of the finished product. So this is the This is the figure or a pictorial view of the definition which we have studied in the previous. Now, manufacturing has another definition which has the economic effect. So we talked about the technological aspect of the definition of manufacturing, and in this slide we are going to talk about the economic effect. So what does it mean? The transformation of materials into items of greater value. So this is the catchword, that the item of greater value. So what does that mean? That a raw material has a value. Let's see, it has a value of 10 rupees. But when we transform that material into an item which is a greater value, let's see, the value raises to 100 rupees. So that is, it means that some manufacturing is being carried out on the material. So let me just read it again. Transformation of materials into items of greater value by means of one or more processing or assembly operations. So there can be some processing operations or assembling operations. So these actually add value. So this is the term which you would come across, add value, or maybe you will also come across a term, value addition. So let me just write it down for you. So manufacturing adds value to the material, or we may say that manufacturing causes value addition to the material. So these are certain examples which are given, in which first is the converting iron ore to steel, then transforming sand into glass, and refining petroleum into plastics. So this is something in which the value is added to the raw material. So this is the economic definition, and in this slide you can see the pictorial view of the manufacturing, the economic definition, that around starting material goes, the starting material comes in, then there are some material in which there's some processing is carried out, and these processes actually add value to the product, and the completed product goes out. So in fact, this is the transformation of raw materials into a final product. And technologically, we say that there are some processes which are carried out which change the shape of the or the properties of the raw material. So this is the technological definition, and due to this technological processes being carried out, a value is added to the finished good, or to the value is added to the raw material. So the value addition is the economic definition. So that if we combine these two, so a manufacturing process, or the manufacturing would cause, number one, the change of shape or the properties of the raw material, and it is going to add value to the raw material. So this is how we define manufacturing. So let us move forward. Actually, यहाँ तक if anybody wants to ask something or contribute something. All right. So it was just a simple definition. So now we are going into the classification of manufacturing industry. So there are three types of industries. One is the primary industry, then secondary industry, and the tertiary industry. So here we go. The primary industry is something like cultivation and exploit the natural resources. So agriculture and mining. So agriculture and mining, these are the example of primary industry. So actually we are taking out the raw materials. We are taking out the ores in mining from the in the primary industry. And what would be the secondary industries? The secondary industry would be to convert the output of primary industry into products. So actually this is the secondary industry, is the one which is the manufacturing industry. So let me just put it down here. So this is manufacturing. We have defined manufacturing, in which we convert the raw materials into products. So secondary industry is actually the manufacturing industry, and then is the tertiary industry, which is actually the service sector. So helping out the secondary industry, helping out the manufacturing or the primary industry, helping out these two will be the service sector, which includes maybe banking, education, then government, some legal services, some trades and transportation. So these are the tertiary industries. So all these industries, they work side by side to from the raw material to the finished product, which is given to or which is made available to the customer. So these are the classes. We can classify. अच्छा अब जरा थोड़ा सा we are now going into little more deep in the classification side of the manufacturing industry, and this will be two types of industries. One is the process industry. I'll just define them. One is the process industry and second is the discrete product. So process industries क्या चीज है? Like something like chemicals, petroleums, basic metals, food. So process industries are something which are actually producing continuously. इसमें कोई break नहीं आता. ठीक है, लाइक जब आप बना रहे हैं इलेक्ट्रिसिटी, जैसे आप कंटिन्यूस प्रोडक्शन में देखें, सो यू आर मेकिंग इलेक्ट्रिसिटी. सो लेट अस लुक एट दिस कंटिन्यूस प्रोडक्शन. सो यू आर मेकिंग इलेक्ट्रिक पावर. सो इलेक्ट्रिक पावर is generated continuously. Then the batch production, something like beverages. So you are making you can make it into batch also. So batch of type 1 and batch of type 2. So these are the process industries in which some chemical process or some uh, uh, some process of this kind is carried out. And the second is the discrete product, in which or part in which the parts are being made, like cars, aircraft, appliances, machinery and their component part. So what would be a continuous production, that it is going to go into discrete parts like this. Okay, I think I have next slide in which you will be able to see this. So let's not put them here. So you will be able to see this in the next slide, that what would be a continuous production for discrete product and what would be a batch production. So let us move forward and see here. So this is the process industry. So this is the process industries in which the input is continuous and the output is continuous. All right. This is the process industry in which input is in batches, but see, the batches are not discrete. You can see the batches are not discrete. So the process industry, so you have input in batches and you have output in batches. Then this is the discrete manufacturing. If you look at this is the discrete manufacturing. Now this is the continuous process, but the parts are discrete. See, the parts are discrete. So 1, 2, 3, 4, these are the parts which are being made. Input is giving in the discrete units and the output is also obtained in the discrete units. And then this is the discrete manufacturing, but it is in the form of batches. So these are the discrete parts, 1, 2, 3, 4, but these are made in batches. So these are the type of products which are being made. So this is batch number 1 will have one type of product, and then batch number 2 maybe is going to have a different type of product. But maybe both the batches have the same type of product, but it is being made in batches. So it is required at one point of time. So you make one batch of the product, then it is required at another point of time. Let's see, after 1 month, so you make batch number 2 of the same product. Okay? So this is how we define the process industry and the discrete manufacturing industry. Now coming over to the manufacturing operation. So these are certain basic activities that must be carried out in a factory to convert raw materials into product. So what could be those of manufacturing operations. We have already talked about them. So those can be some processing operations or those can be some assembly operations. All right. Then there will be a material handling. So material handling will also be part of manufacturing operation. Inspection and testing, and then coordination and control. So let us see the diagram which I have made here. So let us see, we have three, rather 4 points, four stations in which we have, at station number 1 we have lathe machine. At mill we second at the second station we have milling machine. Then painting is being carried out at station number 3, and packing is carried out at station number 4. So a raw material, this is the raw material which goes in. So let me just pick up black. So this is the raw material which goes in this process through station number 1, 2, 3, 4, and then the finished product comes out. So the inspection is carried out at every stage. Inspection is carried out at every stage, and if there is the inspection is failed, so the product or the part goes into reject. So the inspection is carried out at all. Coordination and control is something which in fact carries out which makes these processes, which which process is to be carried out first. As I have put lathe machine or the process of turning in at station number 1. So this is actually the coordination and control, the process control, that on the first stance or the first stage, lathe machine will be used and turning operation will be carried out. And you can see that there is a term which is used here, material handling. Material handling. So material handling is actually transferring the material or the product from one station to another. So this can be done either through, let's see, manual labor, can be done through conveyor, it can be done through crane. So there are different ways and means to carry out the material handling. So let us move forward, and we talk about the processing operations. So these are maybe some of those are written here: solidification process, particulate, deformation, material removal, and then are the property enhancement operations, which are done in the form of heat treatment. And then there can be, let's see, service processing operations, which would be cleaning the surface and treatments and coating the thin film deposition. So these are the surface processes. Shaping processes operation are something which change the shape. Property enhancement is done through heat treatments, and then the finished product is painted or surface treatment is carried out. The assembly operations include the joining operations, which include welding, brazing, soldering, and adhesive bonding, and then the mechanical assembly also, which includes the threaded fasteners, rivets, or interference fits as a mechanical assembly. So I'm just hurrying through all these because you are familiar with this. So whatever we have studied, the operations processes we have studied, so those are summarized here in the form of a chart, in which you can see that manufacturing processes, they are divided into two. So this is the first stage. At second stage, you can see that the processing of operations are divided into two parts, two types, and then further they are divided. So we have studied all this in the previous slides, and this is the summary which you can see in front here. So, यहाँ तक is there any question or any clarification required? All right. If there is no clarification required until here, so we move forward and we talk about some material handling and storage things, which are ASRS, Automated Storage and Retrieval Systems. We can use these for storage. We can use the conveyors and AGVs for material transport system. This is for the use for the transport, material transport or material handling, material transport, and this is the storage. We are going to talk about these uh, in little more detail next week, inshallah. Then inspection and testing, coordination and control. We have already talked about that, how to carry out coordination and control through flexible manufacturing. We will talk a little about flexible manufacturing and assembly lines if we get some time extra. So we will be talking about these two things in detail. But this is actually the coordination and control which makes us, which enables us to go for a flexible manufacturing and assembly line operations. So we have talked about material handling, so I'm not going into detail here. So this is an important diagram or a slide which you should remember in which you should remember that this is the research carried out in 1977. All right, so this is the research carried out 1977, which tells us that how much time is spent in material handling. Since we are talking about material handling, so so let us see here. Let us see this line first. So this is the total time. This is the total time which is spent by a material in the factory, and you can see that only 5% of the time is spent on the machine. Okay, so only 5% of the time is spent on the machine, and 95% of the time is used in moving and waiting, coordination and control. All right, so what do we need to do is that we need to reduce this 95% of the time. So in order to increase our productivity, we need to reduce this time which the part uses or part goes through while moving and waiting. So this can be done with the help of coordination and control, and this is also called process planning. Process planning and coordination control. And now an interesting thing is that out of this 5% of the time, the time spent on the machine is only 30%. 70% is being utilized in loading, positioning, and gauging. Gauging means inspection. We are carrying out the inspection also. So what we need to do is that we need to actually reduce this 70% of the time of 5% also. So it means that in a part which is converted from a raw material to a finished product, it spends 5% of the total time on the machine, and while on the machine, only 30% of the time is spent in carrying out any process. The rest of the time is in loading and positioning. So this is something which needs to be improved. So if we are able to reduce these two times, 95% of the time and 70% of the time, so we are going to make more products in a given time, and that is going to increase our production rate. So we are going to talk about the production rate also today. So please keep this slide in your mind, and what we need to do is, as an engineer, as a process engineer, as an automation engineer, we need to carry out or plan our process in a way which can reduce moving and waiting time and loading, positioning and inspection time. जी कोई सवाल यहाँ तक?
सर ये कितनी पुरानी
दोबारा बोलिएगा.
सर ये कितनी पुरानी रिसर्च थी 1977 तो मॉडर्न कोई नहीं है अब तक.
It is still used as a textbook. It is still used in the textbook, and this research is अच्छा. अब इसी रिसर्च को बेस बना के लोग क्या कर रहे हैं, इन चीज़ों को इन टाइमिंग्स को जो 95% ऑफ द टाइम और 70% ऑफ द टाइम इनको रिड्यूस करते हैं. किस तरह से? मटेरियल ट्रांसपोर्ट सिस्टम्स हैं, जैसे मैंने आपको बताया बेल्ट्स हैं, कन्वेयर्स हैं, ऑटोमेटेड स्टोरेज है. Then there is a just in time concept. Just in time concept is something in which whenever something is required, it should be there at that point of time. उससे पहले भी नहीं आनी चाहिए और उसके बाद भी नहीं आनी चाहिए. ठीक है. सो ये हम थोड़ा सा इन चीज़ों को और डिटेल में पढ़ेंगे. सो द टेक्स्ट बुक जो है वो हमें ये बताती है कि इन टाइमिंग्स को रिड्यूस करने के लिए देन देयर आर सर्टेन वेज एंड मीन्स, जो कि हम आगे ऑटोमेटेड स्टोरेज एंड रिट्रीवल सिस्टम भी पढ़ेंगे अगले वीक में, और हम मटेरियल हैंडलिंग भी अगले वीक में पढ़ेंगे. ठीक है. सो वो इम्प्रूवमेंट के लिए वो हम चीज़ की बात करें. ठीक है. देन इंस्पेक्शन एंड टेस्टिंग है. सो इंस्पेक्शन के लिए आपने product inspection is the examination of the product and its components to determine whether they conform to the design or not. So inspection can be done with the help of measurements or gauging. So you know the measurements, you can use vernier caliper, screw gauge or something like this to measure something. So let us see if you have a rod like this which is being manufactured. So let me just point it out. So if you have a rod like this which is to be made, and it should conform to the dimensions between 10 millimeter to 9 millimeter. It should not be more than 10 millimeter and should not be less than 9 millimeter. So either you use the vernier caliper to gauge it, to measure it, but all the time you have to apply the vernier caliper, then read the reading. The other method could be that you can make two gauges, go gauge and no go gauge. Do you have the concept of go and no go gauge? I hope that you must have studied this while you are studying your workshop practice.
No, sir.
No. Okay. So let me just explain it to you. So let us see. This is the go gauge. ये जो मैंने किया है, and this is the no go gauge. अच्छा, ये मैं थोड़ा सा इसको इस तरह आपको बताने की कोशिश करता हूँ कि this is a gauge which has the distance between these two edges. Let me just take another color. So distance between these two edges is 11 millimeter. Okay. So since I wanted to make a rod which should be 10 millimeter plus minus 1 millimeter. ठीक है. इसको मैंने मीटर लिखा हुआ है. This should be 1 millimeter plus minus 1 millimeter. Let me just put it right. So 10 millimeter plus minus 1 millimeter. ठीक है. So it should not be greater than 11 millimeter and should not be less than 9 millimeter. ठीक हो गया. So now I am going to make two gauges. One has a distance between these two edges as 11 millimeter, and the other one has the distance between these two edges as 9 millimeter. So this is the no-go gauge. So what now I would do? So if you just look at my hand, so this is something the gauge would look like. If you look at my hand, so this is how. Can you see that? Can you see my hand in the camera? जी जी, am I audible?
Yes, sir.
Okay, so can you see my hand in the camera now?
Yes, sir. Idea. थोड़ा सा ऊपर करना है लेकिन idea.
Okay, so now this, let us see that this is the gauge. So if it is an 11 millimeter gauge and I want to make this, I am making this marker. So what I need to, either I am going to measure them with the help of vernier caliper. So each time I need to put it in a vernier caliper and then read how much is the length of this. Otherwise, I can make it an 11 millimeter gauge and I am going to put this here and I will see, okay, it is going into this gauge. So it means that this is not larger than 11 millimeter. So this is what I want. If you can see it in this slide, what I want to make is something which is of 10 millimeter with plus minus 1 millimeter tolerance. So it should not be more than 11 millimeter and should not be less than 9 millimeter. So I'm going to make a gauge of 11 millimeter and I'm going to put it here. So if it goes in, so it means that it is not larger than 11 millimeter. Okay, so this is the go gauge. And I make another gauge which is 9 millimeter. So I'm going to put it here and it is not going into the gauge. It means that this has a larger dimension as compared to 9 millimeters. So it is not less than 9 millimeters. So any of the gauges, if it is rejected by, I mean that if it's a go gauge and the part which you are inspecting does not enter the gauge, so it means it has to be rejected. Similarly, if the gauge is a no go gauge, but your part enters into that gauge, so it means that is to be rejected. So जब मैं mass inspection के लिए जाता हूँ, so when I carry out the mass inspection, so then I do not use vernier calipers or screw gauges. I use go and no go gauges. अब ये go और no go gauges जो हैं, they are standard, they are made with the material, so they do not change their dimension under heat or any other circumstances. So it should not change their. So gauges are made with a material which conform to their size. ठीक है जी? So ये go और no go gauge का concept समझ आया आपको?
Yes, sir.
Okay, that's great. So let us move forward. Coordination and control we have talked about earlier. So these are actually the regulating the processing and assembly operation. So they are to be done in a certain sequence. Okay. Next we come on to the production facility or a factory. So a manufacturing company attempts to organize its facilities in the most efficient way to serve the particular mission of the plant. So plant is to be organized in a fashion so that it can give you the maximum output. अब ये मैं layout की तरफ जा रहा हूँ. पहले मैंने processes की बात की, inspection की बात की, अब मैं वो जो coordination and control के processes हैं उनके लिए एक layout plan करने लगा हूँ अपनी factory कि how do I need to put the machines into my factory. ठीक है? So how do you what things you keep into mind are the types of products which are being made, what type of quantities you want to make, and what is the product variety you want to make. So let us now look at this. So let us see the production quantity. If we can keep into account the production quantity, so the low production units are termed 1 to 100. If you are making a 1 to 100 units, so that would be a low production facility or a low production factory. The medium production would be from 100 to 10,000 units, and a high production would be from 10,000 to millions of units. So now coming over to the product variety, we already know about hard and soft product variety. We have talked about this hard and soft product variety earlier. ये दोनों चीजें आपको पता है. What we need to know here is this, which is important, which says there is an inverse relationship between the production quantity and the product variety. So it means that if you have a higher product variety, so your production quantity would be reduced. And what would be a higher or a hard product variety? That the products, they differ greatly. Products differ greatly. So your production quantity is going to reduce if you have a higher product variety or a hard product variety. So this can be shown here. So this is the graph which is between the quantity and the variety. So if you have a high product variety, so you can actually, you can actually decide that if you have a hard product variety, see here, so it means that you are going to make or you are going to have a low production quantity. Similarly, if you have a low product variety, so you can have a high production quantity. Now, अब ये जो हमारी लो, मीडियम और हाई प्रोडक्शन फैसिलिटीज हैं, इनको हम डिफाइन करेंगे कि ये क्या कहलाती हैं. So the first one is in the low production is the job shop. ये ज़हन में रखिएगा, मैं ज़रा इसको हाईलाइट करता हूँ. So job shop is the term which you are going to come across number of times in the field also. What does a job shop layout? So this is actually the production facility layout, which is called job shop. So it makes low quantities of specialized and customized products. Job shop is something which makes low quantities of specialized or customized product. It also includes the production of components of these products. Products are typically complex. So it means that if they are going to use the specialized machinery, they will carry out the prototyping. Something like space capsule is being made with the help of job shop.
So ये
So the
खराडिया लग रहा है ज़्यादा.
जी सॉरी,
सर खराडिया नहीं है?
ये खरादिया.
Yes sir.
हाँ बिल्कुल, you are very right. बिल्कुल ये खरादिया है कि he has a general purpose machine with it, a lathe machine,
Okay.
and it can make different types of systems, different types of
Customized वगैरह ना थोड़े.
customized कर सकते. So it's a job shop production. ठीक है. Then इसके दो तरह के layouts हैं. One is called the fixed position layout and the other is called the process layout. So what is the fixed position layout? Fixed position layout ये है कि you have a thing which is to be made which is very very large. Something like ship. ये देखो मैंने आपके सामने यहाँ दिखाया कि we are making a ship. So it's a very very large product. So हम क्या करते हैं? The product remains fixed. The worker have a mobile equipment which is taken to the ship and the work is being carried out. So this is called fixed position layout. ठीक हो क्या? ये बात समझ आती है? This is job shop with fixed position layout. Then we can have a job shop with process layout. Process layout क्या है कि एक टाइप के प्रोसेसेस को एक जगह पे जमा कर दो. वी आर मेकिंग, जैसे अगेन आपने खरादिये की मिसाल दी, तो खरादिये ने किसी कोई एक प्रोडक्ट आपके लिए बनाना है. He has two machines, rather he has, चलो हम let's see, we call that it has three machines. One is lathe, the other is mill, the third is a painting machine. So वो क्या करेगा? पहले एक टर्निंग का प्रोसेस करेगा, फिर उसको पार्ट को ले जाएगा मिल मशीन के ऊपर और मिल के ऊपर काम करेगा, फिर उसको ले जाएगा पेंटिंग वाले बूथ के अंदर और उसको पेंट कर देगा. सो दिस इज अकॉर्डिंग टू द प्रोसेस. सो इफ वी हैव अ फैक्ट्री जिसके अंदर वी आर मेकिंग लार्ज नंबर्स एज कंपेयर टू अखरादिया, सो वी कैन हैव मोर देन वन मशीन. सो एक ही तरह का प्रोडक्ट, लेट्स सी, तीन मशीन्स हैं, तीन लेथ मशीन्स हैं, तो तीनों मशीनों पे एक ही तरह का प्रोडक्ट बन रहा है. सो यू आर एक्चुअली इंक्रीजिंग योर प्रोडक्शन रेट बाय एडिंग मशीन्स. ठीक है. सो दिस इज कॉल्ड द प्रोसेस लेआउट, के एक टाइप का प्रोसेस एक जगह पे जमा कर लिया जाता है. सो दिस इज अगेन जॉब शॉप बट अ प्रोसेस लेआउट. तो ये जो प्रोसेस, ये जो लेआउट्स हैं फैसिलिटीज के, ये ज़हन में रखने हैं आपने. देन वी कम ऑन टू द मीडियम प्रोडक्शन. मीडियम प्रोडक्शन में क्या चीज है कि मीडियम प्रोडक्शन में वी यूज द बैच प्रोडक्शन. मीडियम में वी यूज द बैच प्रोडक्शन. सो अ बैच ऑफ गिवन प्रोडक्ट इज प्रोड्यूस्ड एंड देन फैसिलिटी इज चेंज्ड ओवर टू प्रोड्यूस अनदर प्रोडक्ट. सो एक बैच बनाया, देन चेंज करके दूसरा बैच बनाने लगा. सो इसमें क्या चीज है? इसमें देयर विल बी अ चेंज ओवर टाइम व्हिच इज कॉल्ड सेटअप टाइम. इसके लिए हम प्रोसेस लेआउट यूज करते हैं एंड इसमें हम हार्ड प्रोडक्ट वैरायटी को बनाते हैं. एक तरीका ये है कि हम बैच प्रोडक्शन करें. सेकंड क्या है कि वी गो फॉर द सेलुलर मैन्युफैक्चरिंग. सेलुलर मैन्युफैक्चरिंग क्या है? इट्स अ मिक्सचर ऑफ प्रोडक्ट्स इज मेड विदाउट सिग्निफिकेंट चेंज ओवर टाइम बिटवीन द प्रोडक्ट. सॉफ्ट प्रोडक्ट वैरायटी के लिए कैसे, ये देखिए, ये सेलुलर लेआउट है. That you have this is one cell which is being shown to you here. So one cell will include drill, lathe, paint, and any other machine. So we are not carrying out the process layout कि हम तमाम lathe को एक जगह पे इकट्ठा कर दें. So we have encapsulated a set of machines, one type of machine in a set of machines at one cell in one cell. So raw material goes into one cell and the finished product comes out. So you are going to have, let's see, 5 of these cells. So each cell is going to produce one product. अब वो प्रोडक्ट एक तरह की भी हो सकती है, वो प्रोडक्ट डिफरेंट टाइप की भी हो सकती है. सो डिफरेंट टाइप की प्रोडक्ट में हम कौन सी यूज करेंगे? इफ इट्स अ सॉफ्ट प्रोडक्ट वैरायटी तो हम सेलुलर लेआउट यूज करेंगे. ठीक है जी. सो ये मैंने पहले आपको लो प्रोडक्शन के लिए जॉब शॉप का लेआउट दिखाया, जॉब शॉप बताया. जॉब शॉप में हमने दो तरह के लेआउट पढ़ लिए, विच वर द फिक्स्ड लेआउट एंड द प्रोसेस लेआउट. फिर हम इधर आ गए जो मीडियम प्रोडक्शन था, इसके अंदर हमने दो तरह की चीजें पढ़ ली, या बैच प्रोडक्शन होगी या सेलुलर मैन्युफैक्चरिंग होगी. बैच प्रोडक्शन में हम प्रोसेस लेआउट यूज करेंगे एंड वी विल प्रोड्यूस हार्ड प्रोडक्ट वैरायटी, एंड सेलुलर मैन्युफैक्चरिंग में हम सेलुलर लेआउट यूज करेंगे फॉर द सॉफ्ट प्रोडक्ट वैरायटी. हम थर्ड की तरफ आ रहे हैं. मैं रिपीट इसलिए कर रहा हूं कि ये चीजें आपके जहन में बार बार सुनने से आपके जहन में बैठनी शुरू हो. सो द हाई प्रोडक्शन. हाई प्रोडक्शन क्या है कि जिसमें we want to manufacture large quantities, we produce large quantities. So इसके लिए we need to have the equipment which is dedicated to manufacture one product only. ये देखिए बड़े गौर से देखिएगा, यहाँ पे टर्म लिखी हुई है one product only, one product. So we are making in very large numbers. So equipment is dedicated to make one product. So we equip our equipment or make our equipment or dedicate our equipment to make only one product. So this is a customized equipment made to manufacture something like glass. So ये glass है, मैं इनको large number में करना चाहता हूँ, बनाना चाहता हूँ, तो I am going to get a machine which will be able, which is configured to make glass. ठीक है. सो इसमें क्या है कि जी वी नीड, इसका जो टिपिकल लेआउट है दैट इज द प्रोसेस लेआउट. ठीक है. सेकंड जो है दैट इज द फ्लो लाइन प्रोडक्शन. सो इसमें क्या है, द मल्टीपल वर्क स्टेशंस आर अरेंज्ड इन अ सीक्वेंस. हम पहले भी इसको देख चुके हैं. सो एक मशीन, दूसरी, तीसरी, चौथी इन अ सीक्वेंस, और एक तरफ से मटेरियल एंटर होता है, दूसरी तरफ से आउट हो जाता है आफ्टर कैरिंग आउट दोस 4 types of processes on the raw material. So if I look at this high production के लिए, so आप देखिए this is the flow line. This is the flow line production. The work is flowing from one side and it is moving and the work is being done at different stations. So हर station पे उसके ऊपर different type का काम हो रहा है and the work unit is going out. So this is used for the high production. Now I need you to concentrate on this. We have already seen this diagram जिसमें कि we use the product production quantity, हम product की variety और production quantity के ऊपर एक ग्राफ बनाते होते हैं. So आप देखिए, आपको याद होगा इसी के दरमियान हमने यहाँ पे प्रोग्रामेबल ऑटोमेशन लेके आए थे जॉब शॉप के लिए, आपको याद होगा. फिर हम यहाँ पे लो प्रोडक्शन लेके आए थे, ये भी आपको याद होगा. सो अब हम क्या करने लगे हैं कि हम इन्हीं दो क्वांटिटीज के दरमियान अपने लेआउट्स को लेके आने लगे. सो जॉब शॉप फिक्स पोजीशन लेआउट, ये देखिए जॉब शॉप with a fixed position layout, so you will have a high product variety but a low production quantity. So actually this figure or this graph gives you an idea. This gives you an idea that which type of layout and which type of production facility you should be using while you want to make a certain number of products. तो किस प्रोडक्शन क्वांटिटी के लिए आप कौन सा लेआउट यूज करेंगे और कौन सी टाइप ऑफ मैन्युफैक्चरिंग यूज करेंगे. सो दिस गिव्स यू अ होल लॉट ऑफ understanding that you would be able to make out that if you want to go with a batch production, so it means that your product variety will be reduced, your production quantity will increase, so you can then use the process layout for this purpose. तो इस डायग्राम को काइंडली जरा गौर से दोबारा देखिएगा और इसको I have introduced a term here as a bottleneck station. Bottleneck station is something which takes the maximum time. ठीक है. Let's see. ये 1, 2, 3, 4 जो है ये हमारे मुख्तलिफ स्टेशंस हैं. And the process time on each station is 1 minute. Number 2 पे 1 minute. Number 3 पे 3 minutes. Number 4 पे 1 minute. So the process time, the station which is taking the maximum time is called the bottleneck station. So bottleneck station जो है that will actually determine the cycle time of your product. बेशक मशीन नंबर 1 1 मिनट में अपना काम कर लेती है, बट आपका जो ये जो प्रोडक्ट है ये 3 मिनट ही लगाएगा अपने बनने के अंदर. सो बॉटलनेक स्टेशन को टाइम को रिड्यूस करने के लिए वी हैव टू कैरी आउट सम we have to think and carry out some change. So one change could be that you improve the process and reduce this 3 minutes time to let's say 2 minutes. अगर 3 मिनट्स टाइम जो है वो 2 मिनट्स में नहीं जा सकता, बट आप कहते हो कि मुझे प्रोडक्ट तो यार 3 मिनट से पहले चाहिए, ज़्यादा प्रोडक्ट चाहिए. सो व्हाट यू कैन डू दैट यू कैन हैव द पैरेलल स्टेशंस. तो आप 3 नंबर जो स्टेशन है वो पैरेलल में आप 3 लगा लें. सो अब 1 मिनट में आपका प्रोडक्ट जो है वो कंप्लीट हो जाएगा. सो आफ्टर एवरी 1 मिनट यू आर गोइंग टू गेट अ प्रोडक्ट. डू यू अंडरस्टैंड दिस? ये बॉटलनेक स्टेशन का कॉन्सेप्ट समझ आया आपको? जी, I need somebody to respond please that have you understood the bottleneck station?
Yes sir.
Okay, that's great. So let's move forward and talk about बिल्कुल सिंपल सी हम मैथ्स करने लगे हैं. कोई इसके अंदर चीज मुश्किल नहीं है. So just look at this, that if we have a production quantity which is denoted by Q, if we have a production quantity which is denoted by Q, let me just, this is denoted by Q, and we have a product variety which is denoted by P. So product variety means that, let's see, P1 is the product variety 1. So we are actually making 10 parts as P1, 20 parts at P2. So we will have total number of products which is QF. So those can be given by this 30. So QF is that how many parts of product variety number 1 are being made and how many parts of product variety number 2 are being made. Simple है, कोई इसमें ऐसी बात नहीं. Then product variety we know, hard and soft product variety है, we know this. ये जरा थोड़ी सी गौर से देखने वाली चीज है कि product की complexity would depend on NP, which are number of parts in the product. कि प्रोडक्ट के अंदर कितने पार्ट्स हैं. सो इफ एनपी इज हायर सो द प्रोडक्ट इज मोर कॉम्प्लेक्स. 1. नंबर 2, पार्ट कंप्लेक्सिटी. अब ईच पार्ट, एक प्रोडक्ट की कंप्लेक्सिटी है विच इज डिटरमिन्ड बाय द नंबर ऑफ पार्ट्स विच आर इन द प्रोडक्ट. देन ईच पार्ट की एक अपनी कंप्लेक्सिटी है विच इज कॉल्ड पार्ट कंप्लेक्सिटी, विच इज द नंबर ऑफ ऑपरेशंस आर बीइंग कैरिड आउट टू मेक अ पार्ट. आई रिपीट, प्रोडक्ट की कंप्लेक्सिटी क्या है कि उसके अंदर कितने नंबर ऑफ पार्ट्स लग रहे हैं. उन पार्ट्स की कंप्लेक्सिटी क्या है कि वो कितने नंबर ऑफ ऑपरेशंस में मैन्युफैक्चर हो रहे हैं. सो ये प्रोडक्ट और पार्ट की कंप्लेक्सिटी. अब इसको हम जरा थोड़ा सा मैथमेटिकली देखेंगे. यहाँ ये एक मैट्रिक्स है, गौर से देखिएगा. दिस इज NO. NO was the number of operations. So if we have more number of operations, यानी कि number of operations are more than 1, so the Plant makes individual components. Each component requires multiple processing steps. No assembly, so NP is equal to 1. So it means what is happening, this is called part producer. This type of plant is called part producer, which is making only uh, part which has more than one number of operations. So इसका मतलब है कि ये कोई complexity हमारे ज़हन में आ गई. ये मैं complexity को अभी बना लेके आ रहा हूँ. अब देखिए again वन नंबर ऑफ पार्ट, ये देखिए गौर से, इस वाली में देखिएगा जो कि हैंडीक्राफ्ट शॉप है. It has only one number of part and one number of operation. जैसे मैंने कहा था ना, एक लकड़ी है उसको कार्विंग कर रहा है, तो एक ही पार्ट बन रहा है और एक ही नंबर ऑफ ऑपरेशन है जो कि कार्विंग का है. सो दिस इज कॉल्ड जॉब शॉप. ठीक है, अब आगे आ जाए. एक असेंबली प्लांट है. आई एम गोइंग हियर. दिस इज एन असेंबली प्लांट. असेंबली प्लांट में क्या है, one operation is required to assemble each part. So it has more than one parts. It has more than one part, but एक ही operation है जो carry out हो रहा है. So it will have a complexity level. This is the vertically integrated plant. This is the most complex. That it has more than one number of operations. It has more than one number of operations and it has more than one number of parts. So इसमें देखिए वो जो complexity है वो दोनों जगह पे आ रही है. Parts में भी complexity आ रही है और product में भी complexity आ रही है. ठीक है. So ये जो एक आपके सामने मैंने एक मैट्रिक्स दिखाया है, ये आपको बताता है कि how we can define the complexity of product and complexity of the part. Okay, so let us move forward. और हमने जो अभी पहले मैथमेटिकल दो तीन इक्वेशंस पहले देखी थी, उनको हम थोड़ा यहाँ देखने लगे हैं कि the total number of products will be the multiplication of P and Q. जबकि P क्या था, these QF was the total number of product. P was the product variety, a number of parts produced in one type, and Q was the number of parts produced, and P was actually the type of products which were made. So total number of parts produced would be given by this simple multiplications here, and the total number of operations will be given by this formula. कोई कॉम्प्लेक्सिटी नहीं है, सिंपल मल्टीप्लिकेशन. तो मैं जस्ट आपको यहाँ पे एक एग्जांपल सॉल्व करवाने लगा हूँ. लेट अस रीड इट आउट. Suppose a company has designed a new product line and planning to build a new plant to manufacture this product line. Okay, ठीक है. The new line consists of 100 different product types. So ये P हो गया. So there are 100 different product types. Okay, ठीक है. So this is P. For each product type, the company wants to produce 10,000 units. और ये Q के बराबर हो गया. This is Q. The product average 1,000 components each. So this is NP. So हर product के अंदर 1,000 components. And the average number of processing steps required for each component are 10. So this is NO. Determine that how many products we want to make, how many parts will be produced, how many production operations will be required each year, and how many workers will be needed for the plant if it operates one shift 250 days. So one shift actually is 8 hours. ये देखिए. Or 1 year is taken as 250 days in a production unit. So if a production unit works for 250 days in a year, so it means that it is working to its full capacity. ठीक है जी. सो ये अब वो मैंने आपके सामने यहाँ सारा सॉल्व कर दिया कि नंबर ऑफ यूनिट्स कितने बनेंगे. सो दिस इज P इंटू क्यू. सो ये मैंने इसको मल्टीप्लाई कर दिया. टोटल नंबर ऑफ पार्ट्स कितने हैं, इसी पी क्यू के साथ एन पी को मल्टीप्लाई कर दिया तो टोटल नंबर ऑफ पार्ट्स आ गए. टोटल नंबर ऑफ ऑपरेशन, सो पी क्यू एन पी को एन ओ से मल्टीप्लाई कर दिया तो टोटल नंबर ऑफ ऑपरेशन आ गए. Total time to perform these operations, so each operation take 1 minute, so it is 1/60 hours. So total time taken, ये इन ऑपरेशंस को कैरी आउट करने के लिए, टोटल टाइम टेकन इज these many hours. So if a worker works for 2000 hours per year, 8 shifts, 250 days a week, so the total number of workers would be required 83,333. If you want to make these number of products in less than a year's time, let's say 6 months time, so what you need to do is that you need to increase one more shift, but your workers would be doubled. Or if you want to increase the production, or if you want to finish it off early, so you can go with a extra time, जिसको कि हम overtime कहते हैं. So we can go with an overtime also. This is the second operation or second option with us would be to go with the overtime. But ये देखिए कि हम ऐसा नहीं कह सकते कि जी मैं एक ही वर्कर से 2 शिफ्टें करवा लूँगा, ऐसा नहीं है. So वो overtime would always be 2 hours overtime, something like this. ठीक है जी. So let's see, अगर मैं आपको इसी एग्जांपल में कहूँ कि जी अगर आप ओवरटाइम कर लें तो फिर आप कितने अरसे में ये प्रोडक्ट बना सकते हैं. So I can frame this question in certain different ways to test you in the exam. ठीक है जी. So please keep this thing in your mind. मैन्युफैक्चरिंग की कैपेबिलिटीज या उनकी लिमिटेशंस क्या हैं? फिजिकल लिमिटेशंस मैन्युफैक्चरिंग क्या है? टेक्नोलॉजिकल
सर
जी जी
सर ओवरटाइम हम अपने किस तरह करें कि उनके एक्स्ट्रा आवर्स ऐड कर दें थोड़े से.
जी मैं और एक्सप्लेन कर देता हूँ. ओवरटाइम क्या है कि जो आप एक शिफ्ट को, सो आप क्या कर देते हैं, आप कहते हैं कि जो आपने यहाँ देखा ना कि 8 आवर्स की शिफ्ट है जो हमने पहले देखा था, अब हम कहते हैं कि हम 10 आवर्स की शिफ्ट चलाएंगे. ठीक है. So what I am doing is that I am not increasing the number of workers, but I am giving, I am taking extra time from the same workers to work for me. So 8 की बजाय मैं 10 hours उनसे करने लग गया, काम करने लग गया. So I am going to pay them for 10 hours a shift, एक शिफ्ट में, तो वो that will be an overtime. जैसे हम कहते हैं ना कि हमारे ऑफिस आवर्स हैं लेट्स सी 9 to 5, और हम कहते हैं कि यार अच्छा, हम किसी वर्कर को कहते हैं कि यार आज थोड़ा काम ज़्यादा है, प्लीज़ वर्क फॉर 2 hours मोर. वो कहते हैं ठीक है, आई कैन वर्क फॉर 2 more hours, बट मुझे ओवर टाइम मिल जाएगा. सो उसकी एक जो तनख्वाह थी जो कि उसकी 8 hours a day के हिसाब से थी, तो उसको कुछ एक्स्ट्रा पैसे मिल जाते, तो वो विलिंगली अपना काम कर लेता. ठीक है. So this is the overtime. ठीक है, ये बात समझ आई? Okay, that's great. Okay. So limitations और capabilities क्या हैं? The technical and physical limitations of a manufacturing firm, each of its plant, वो क्या हो सकती हैं इनकी 3? Technological processing capability, यानी कि the available set of manufacturing processes क्या हैं? कुछ processes उसके पास है, कुछ उसके पास नहीं है. Let's see, उसके पास मिलिंग मशीन नहीं है तो वो मिलिंग ऑपरेशंस नहीं कर सकते. So ये टेक्निकल. देन फिजिकल साइज एंड वेट ऑफ द प्रोडक्ट, कि यार इतना बड़ा प्रोडक्ट मेरे पास जो लेथ मशीन है वो इसके अंदर फिट ही नहीं होता. सो साइज और वेट की लिमिटेशन है. सो आपने देखा होगा कि जो भी आप लेथ मशीन की बात करते हैं तो उनका एक बेड साइज होता है, आप उससे बड़ी जॉब उसके ऊपर नहीं बना सकते. ठीक है. एंड द थर्ड इज द प्रोडक्शन कैपेसिटी, कि आपका एक गिवन टाइम में आप कितनी क्वांटिटी प्रोड्यूस कर सकते हैं, तो आपका मशीन का प्रोडक्शन रेट क्या है. सो दीज कैन बी द लिमिटेशन. और ऑन द अदर हैंड दीज कैन बी टर्म्ड एज द कैपेबिलिटीज आल्सो. एक चीज नहीं है वो लिमिटेशन है, जो चीज है वो आपकी कैपेबिलिटी बन जाती है. ठीक है. दिस इज योर रीडिंग असाइनमेंट विच इज कॉल्ड लीन प्रोडक्शन. इसका जो क्रक्स है वो लास्ट लाइन में दिया हुआ है. लीन प्रोडक्शन मीन्स डूइंग मोर विद लेस बट स्टिल डूइंग इट बेटर. सो दिस इज कॉल्ड लीन प्रोडक्शन. ये आपकी बुक में गिवन है. सो प्लीज गो थ्रू दिस. और एक लिए लीन प्रोडक्शन का एक जो उसके अंदर एक आर्टिकल कह लें या एक हेडिंग है, उसको प्लीज जरूर पढ़ लीजिएगा. ठीक है जी. सो वी टेक अ ब्रेक फॉर अबाउट until 10:10. I'll remain online and we will take a break until 10:10 and then we will start the next जो हमारा लेक्चर है 13.2, जो कि ज़रा शॉर्टर है और वो हम उसको 10:30 तक फिनिश कर लेंगे. सो अभी कोई क्वेश्चन तो नहीं है आपका यहाँ पे? ओके. सो मैं इसकी रिकॉर्डिंग ऑफ करता हूँ.